Good morning everyone. I am Mr. P. Naresh Kumar, the Assistant Professor of CSE Department. So today we are here to discuss about the flat subject, formal languages and automata theory. Why we need to study this subject? First of all, we have to know what is the importance of the subject and why we need to study, and then we have to go for the concepts. So here I have given you about formal languages. What do you mean by a formal language? What is the difference between a formal language and informal language? Simply we can say that formal language is nothing but a language which is meaningful. So let me give you an example. If I ask you, tell me the name of an animal which is having 4 legs. Of course, every animal is having the 4 legs. So you can't say the name of an animal because there is no information, particular information which is required to say what is the exact name of an animal. So that is the informal language. Suppose if I give you the task that tell me the name of an animal which roars and is having 4 legs. Automatically you say it is a lion. How can you say it is a lion? Because here I am giving you the information of the word roaring. Roar. It is the special feature of a particular animal. So this is the meaningful and a complete information. So this complete and meaningful information is called a formal language. So for these type of languages, we need to design the graphical representation, automata theory. So automation. So automation, automatically this word will be occurred in many number of subjects or many number of concepts like artificial intelligence and each and everything. So this flat formal languages and automata theory, this concept is the basic and starting point of the design thinking and all the other concepts which are trending in real-time environments in nowadays. So this subject is completely, simply we can say that completely tells that designing a graphical representation for the meaningful data. Okay, so this is the meaning of this title. So here let me introduce you the basics of this concepts. That first it was introduced by this formal languages and automata theory concept was introduced by Dr. Alan Turing. He introduced this concept in 1930s. So what is the goal? Why he has introduced this automata theory? Because he has one goal that he want to separate the working capacity of a computer, in that what a computer can do and cannot, what it can do and what it cannot do. So he want to separate. So he want to know what a computer can do and what a computer cannot do. So for this purpose he has introduced this concept. So he has taken the formal languages. So he has designed a graphical representation. He has better understanding. So by that he has separated. So in 1930s he introduced this flat concept. In 1950s Noam Chomsky, so he has introduced the concept of regular expressions and grammars for this flat concepts, formal languages and automata theory. So he wants to tell that, so we need to design the representation for regular expressions, a format, simply we can say that a formula, a syntactic representation, an expression representations, or a grammar. Here if we have a grammar, we can design a regular expression. If we have a regular expression, automatically we can design a automata, nothing but a graph, we can design a graph. So he has introduced the concept of regular expressions and grammars. So he wants to tell we can not only consider a basic natural language, we can also consider the grammars and the regular expressions. So, and in 1969, S. Cook, he has extended the concept of flats, nothing but he has extended the concept of Alan Turing's flat concepts. So, here he wants to specify that what is the complexity of the task and how it can be performed. For example, if I have given you x and y, two tasks, let us say x task was completed and y task was unable to complete. So, this can be done by using the Alan Turing concept. So, what is the concept of Alan Turing? He wants to say what a computer can do, what a computer cannot do. So, this will be easily defined by using this Alan Turing concept. So, what is the extension as introduced by S. Cook? Nothing but, for example, X task has been completed, okay. How complexity is the task? Is it completed easily or tough? Is it a high complex or less complex? So, here it will be called as this concepts, actually he wants to mention as NP hard problems. So, what he wants to tell you is nothing but a task can be computed easily or it can take much time. So, here if it is completed easily, so there is no problem. If it is taking more time, nothing but it is a more complex, so then we need to concentrate on these complex issues. Just for example, let us check the differences between C programming and Java programming. C is a procedure oriented and it is highly complex. Why? Because each and every code will be written in the main program directly itself. While comparing with Java program, Java is an object oriented programming. A program will be divided into a number of modules and finally it can be included in the main programming. So, an object oriented program. So, the complexity what you have faced while compiling in the C programming will be reduced by introducing the Java program. And again now in the future, in the real time environment nowadays, we are introduced with many number of different and high level languages like Python programming, PHP. So, when you compare each and every language, so after the introduction of the new language, for every new language which was introduced, the complexity was being reduced. So, to reduce this complexity, so we have to find what is the easy and what is the complex task. In case of unable to perform, suppose as we have given y task was not performed. So, here also we have to concentrate here why it was not completed, why it was not computed. Okay. So, what are the actions to be taken to solve this issue? For example, robots in earlier days, robot is an idea, robot is a plan, but now robot is a reality. And nowadays time machine is a plan, already we are working on the time machines. So, it is incomplete task, in future it might be completed. So, it might be a reality. So, S. Cook what he wants to introduce is nothing but he has to separate easy tasks, complex tasks or unable tasks. So, based on these tasks what we have to concentrate, so he can decide, we can apply the logical thinking and automatically the problem is to be reduced. So, based on all these concepts we have introduced this flat formal languages and automata theory, and so it can be used in the designing of real world systems. So, this is the basic concepts of this subject, and now let us know about what is the structural representation of this formal languages and automata theory. So, the structural representation should be concentrated on two issues. One, what a computer can do, and second, how effective it has to do. What it can do, okay, and how effective it has to do. In generally, if we contact any software development persons who is working in the real time industry, so if we ask them what is the best code, he can say that a code which was developed in less number of lines and more effective. Okay, more effective than nothing but it is logically satisfying all the requirements what was introduced in the concept, but the coding was taken in very less number of lines. So coding is completed and it should be completed effectively. So these two considerations are the main important for the structural representations. Even if you draw a diagram, so we need to complete the diagram in the less number of representations, less number of state representations, and it must be satisfy whatever the related types of strings what we have given. Okay. So here decidability and logical thinking, these are the two main efforts we need to apply. So we have to think logically, we have to think effectively, and we have to decide what we have to do. So this is the structural representation. So diagrammatic representation, we will go for the diagrammatic representations once. So here the formal languages and automata theory, the diagrammatic representation will consist of input symbols, and next states. Okay. So here a state can be represented. Here the states are two types. One, initial state, and two, final state. An initial state can be represented with circle, which was included a small link. Okay. A final state, this is called an initial state. A final state will be represented with double circles. Okay. This is called a final state. It will be look like same as in the data structures, but it is not same. The diagrammatic representation will be look like same as in the data structures concept, but it is not same. Why? Because in the data structures, this will be called as a node, and what are the elements you have considered, it will be represented in between the nodes. But here we have to consider it as a state here. So whatever the naming you have to give here, it is of your choice. So there is no issue. That input symbols will be represented on the arrow links here. Okay, input symbols either 0, 1, A, B, X, Y, whatever it might be. You can take whatever the input symbol which is required. Okay. So here the set of input symbols, whatever you have taken, it will be represented with sigma here. Suppose if you have taken 0 and 1 are the input symbols, sigma 0, 1. So this is the input symbols representation. In this subject, mainly the type of representation is very important in exam point of view and also to understand easily. Okay. So the total number of states will be denoted by capital Q. A small initial state, already what we have given here, it will be denoted by Q naught, and a final state, it will be denoted as capital F. Whatever the diagrammatic representation you have taken, we have a transition function, it will be represented as dou. Okay, this is the transition function. In this subject, whatever the type of diagram you have taken, the input symbols, total number of states, Q naught, F, it can be easily identified, it can be easily represented, but there will be a difference in transition functions. Okay, the type of diagram consists of a different type of transitions here. So for example, let me take you a small diagram as an example, not a full concept. Okay, just I have entered a room, just I want to ask you that switch on and off the light once. Okay, here I am giving you two tasks. One, switch on and off the light once, and second task is switch on or off the light continuously. Third task, switch on off the light twice. These are the three different types of tasks I have given. So, for these three different types of tasks, so we have to represent a diagrammatical representation, we have to give it. Okay, this is the formal language and automata theory. The diagrammatic representation will be drawn for these three different types of tasks. So, already we have given that the starting state, initial state. Okay, so now I am in the initial state. Let me take as Q naught. So, it can be taken as of your wish. You can take a Q naught, A, B or X, Y, whatever it might be. Okay. Now, suppose first step, actually basically in the room the switch will be the light will be in off state. Okay. Now, on. First, so I have on the switch. So, this is the input symbol or this is the action I have performed here. Automatically you will be in the next state. So, in this state you are in the on state. Okay. Next, again what I have given, off. Okay. So, now you are in the next state, Q2. So, is this diagram will be suitable for all the three tasks what I have given? No. Why? Because, so here I am in the initial state, I have performed an operation on, switch on, now I am in the another state, now I have performed another operation off and I have completed. So, I have mentioned here Q2 state as a final state, nothing but the task is completed, the task is completed, the information is clear, it is a formal language. Okay. So, this diagram will be suitable for this one here. Okay. Let me take another one, second. It will not be suitable for second task and third task. Why? Because here the transition is only once, it was happened only once, but in the second and third task I am asking about continuously or twice, nothing but more than once. So, this diagram is not suitable for second and third tasks. Okay. So, first task is suitable. Okay, let me take another type of diagram, whether I can check whether all the three will be satisfied or not. Okay. Next, let me take Q naught, this is the initial state. I have performed one operation on Q1, and next if I perform off here, I have not mentioned the final state here. Okay, just I have designed a diagram on, off. So, is this representation suitable for all the three? Means first two will be exactly suitable and second logically suitable, but it is not complete. Why? Because, so switch on and off the light once, nothing but I am in the initial state, I have switched on here and second and again off, automatically in the initial state on off. I can do one or more than once, one or more than once. Here I have asked you continuously. I did not mention how many number of times you have to switch on or off, but here I have mentioned. So that is why I have not mentioned here the final state. You can say, sir, already you have completed on and off, sir. Let me put Q naught is the final state. But I am asking again continuously. Continuously. Okay, it will be repeated any number of times, many number of times. So, 1, twice, thrice or n number of times. Okay, so this type of diagram will be suitable for once continuously and twice also, because on and off twice, on and off twice. So, completely. If I have not suitable, if I have not mentioned a final state here, so it will be suitable for 1 and 2 only, because I did not mention twice here. I am not giving the information of completeness. Twice, this is the target, that is the target number of times how you have to perform, how many times you have to perform. So, automatically you will be in any one of the state, you will be in the final state. So, here I am giving the on and off twice, means automatically on and off, you can take the final state. If I say continuously, so automatically you can say only states. So, here what I want to say is, for each and every task which is having a small difference, there will be a difference in the diagrammatic representation. So, that is why I have given you there that logical thinking must be applied before designing the diagram. Once you, first of all, you have to concentrate on what the task was given, read many number of times until you get an idea, think logically. So, decide and draw the diagram in a way that it should be complete and it should be effective. So, here I have taken 3 number of states, here I have completed 2 only. Based on the designing, coding will be implemented. So, if you use high level of designing, automatically the code will be in many number of lines. So, it is not effective. So, this is completed, this diagram is also completed, but this is ineffective. Why? Because this task is suitable for only one, all the 2 are not suitable, but in this diagram representation all the 3 are suitable. So, in one diagram many number of tasks are suitable. So, one code, more information. So, this is effective. So, this is the way we need to design a diagram. Okay. So, here for a particular diagram we can say, then we can represent in a tuple representation. For every type of diagrammatic representation, basically we will have 5 tuples, and some of the diagrams we will have 6 tuples also. So, how can you denote? Is nothing but it is represented in flower braces. First of all, you have to represent here Q. Okay, number of states, number of input symbols, transition function, and next what is the initial state and what is the final state. For example, suppose this is the final state I have mentioned here. So, for this diagram, so how we have to represent is nothing but what are the number of states? Q0 and Q1. What are the input symbols? On, off. So, transition function, so this will be denoted same here, because this is different in each and every diagram and it will be represented in the state table. Okay. And what is the initial state? Q naught, and final state here double circle, this is also a final state, initial state and final state. This is the information. Okay, if you have a diagram, you can easily draw a state table, a state diagram and a tuple. If you have any one information, you can design other two easily. Okay, so here based on these strings, so we need to discuss about the conceptual schema here. So conceptual schema concentrates on the alphabets, strings, language. Alphabets are nothing but the symbols, input symbols. So how the input symbols are represented? It will be represented by sigma. For example, okay, 0 and 1. So these are the input symbols I have taken here. So these are the input symbols, alphabets. So 0, 1 here. Strings, a combination of alphabets. A combination of alphabets. For example, so 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0. So any type of combinations, but it is a group of alphabets. It doesn't have a meaning or not a meaning, it does not consider, it's just a group of alphabets, input symbols. This is called a string. So in these strings, you need to concentrate on length of a string and power of a string, power of input symbols. Power. So this length will be represented by W. Okay. For example, if I have taken a string like 1, 1, 1, 1, 1, 0. So how many input symbols are there in a string? 0, 1, 2, 3, 4, 5. So the length will be 5. It should be represented with W. And next, the power of a string, it will be represented by sigma power k. So the number of occurrences here, based on the power of a string, we can get the meaningful representations, meaningful considerations also of the input symbols. For example, if I have taken 0 and 1 are the input symbols, if I have given sigma power k, if k is 0, automatically sigma power 0 it is equal to 1, so no need to concentrate, it is common. If k is equal to 1, so then sigma power 1 and nothing but sigma, automatically it is 0, 1. So sigma or sigma power k in k, if k is 1, okay, sigma or sigma power k if k is 1, in the case if the k is 1, both are same. Okay. Next, if k is equal to 2, power is equal to 2, sigma power 2, so twice. So combination of these input symbols twice. So how can we represent it is 0, 0, 0, 1, 1, 0, 1, 1. Simply in 10th class we can know that 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, same way. So if you take it as sigma cube, automatically it will be represented as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 8. Total 8 representations, 2 cube, 2 power 3, 8. So think in this way, and based on that you can draw here, you can consider the strings here. It will be easy to understand, it will be easy to consider the input strings automatically. So the languages, a language is nothing but a combination of strings. So, alphabets, string is a combination of alphabets. So, language is a combination of strings. For example, 0, 1, these are the alphabets. 0, 0, 1, this is a string. 0, 0, 1 plus 1, 1, 0. So, this is a string and this is a string. So, combination of two strings, it is called language. So, do not think the language is nothing but not only a natural language, it is also should be represented as a regular expressions and it is a grammar. So, this is called a language, a group of strings. So, here we have to consider a language should be like a group of strings. So, this is what about the formal language and automated theory, the basic concepts. So, if we know about how we need to draw a diagram, for the given task, so automatically it will be easier. If you doesn't know nothing but if you don't have the logical thinking, if you doesn't know how to draw a diagram for a task, it will be very complex. It is a very severe task in case of real time environment of software development, because if the design is wrong, automatically code is wrong, automatically the project will be lost. So, the keep concentrate on designing. So, while designing, so this is the most important, the structural representation. So, logical thinking and decidability, these two efforts are plays a key major role in designing the diagram here. First of all, understand the task what we have given. So, think about how it should be designed in a way that it should be designed effectively and then decide and draw the diagram. So, it will be completed. So, these are the basics. So, why we need to design, how it was introduced, how it should be completed easily. Okay. So, in this concept we will have deterministic finite automata, non-deterministic finite automata, with epsilon transitions. So, different types will be available. So, and finally, we will have Turing machines. We will have the Turing machines which we are using in real time environment nowadays, Turing machines. Already, as you have completed studying about this data structure subject, same the format will be same, that in the data structure subject first you start with arrays, based on the representations, based on the issues in the present topic you will introduce the next. In the same way, finally you will get heap representations, so which is effective. In the same way we will start with the data DFA, NFA, and finally we will go for the Turing machines. It is very easy to understand, just you need to concentrate on the type of representations and what it does. A small difference will be there, so based on that you need to concentrate. So, thank you for giving the opportunity. Thank you very much.